Let's prepare for the Unit 4 test on transformations. The first question on the study guide shows you a triangle with vertices A, B, and C, and the coordinates are provided for you. They're asking you to perform this transformation, which is a translation. And you can either do it mathematically by following this math rule of adding 5 to all the x coordinates and subtracting 6 from the y coordinates, or you can understand that this is a movement 5 units to the right and a movement 6 units down, and count those boxes. So if we were to use the mathematical rule, I would take the point -5, 1, and I would perform these two math steps. I'd add 5 to the x coordinate and subtract 1 from the y. That would leave me with a 0 and a -5. Now if I count the boxes for A, 1, 2, 3, 4, 5 units to the right, 1, 2, 3, 4, 5, 6 units down, you'll notice I'm at that same point, 0, -5. Call it A prime. You can either count boxes or you can use the math formula. 1, 2, 3, 4, 5 units right, 1, 2, 3, 4, 5, 6 units down. If we do the math on that, the point was -8, 6. The math was add 5, subtract 6, and it does indeed take us to -3, 0. I'm going to perform the math rule for the last point. The last point C is -2, 4, -2, 4. I'm going to add 5 to the x and subtract 6 from the y. That will give me the point 3, -2. +3, -2. There is C prime, that was B prime. Connect each vertex, and now you're done. Question number 2 is the same, except this time they're asking you to rotate 90 degrees clockwise. You cannot count boxes for a clockwise rotation. You simply follow this rule. You swap the order of the coordinates, and then you draw an arrow in the clockwise position to tell you who is going to change sign. So that arrow in the clockwise direction says that the new second number will change signs. The points are provided for you. So if R is 6, -7, I will swap the order of the numbers and I will change the sign of the new y coordinate. Do the same thing with S. It's missing a number here, but S is 2, -4. So I'm going to swap those numbers, -4, 2, change the sign of the new y. Again, last move, swap the order of the numbers, change the sign of the second value. So now I'm going to plot these points, -7, -6, that is my new R prime, -4, -2, that is my new S prime, and -4, -9, that is my new T prime. Connect each vertex, and now we're done. Number 3 asks you which one is the math rule for a translation 3 units to the left and 2 units up. So left and right affects the x coordinate, and up and down affects the y coordinate. Whoops, I wrote a y there instead of 2. I was getting ahead of myself. So there we have the rule, and we find the matching multiple choice. Number 4 asks you about 180 degrees clockwise rotation. With 180 degrees rotation, you simply change the signs of both coordinates. So this 6 will become a -6, and this -9 will become a +9. So -6, 9. Question number 5 asks you to determine which sequence of transformations can take you from the black shape, PQR, onto the red shape, XYZ. So when I look at these letters, I see that P is the first letter and X is the first letter, so they are corresponding points. So this point has to go to X. So my original point P is 2, 1, and my final point X is -2, 0. So I'm trying to find a sequence that will take me from the blue point, P, to the red point, X. So it looks like the first one option is a reflection over the y-axis and then shifting 1 unit to the right. Let's check the math on that. If you reflect over the y-axis, you will change the x coordinate. That would be my middle point, right before I get to my final destination. Now if I translate 1 unit to the right, I would be adding 1 to this x value. And that would not give me this number. So I'm going to cross off option A because that did not work. So I'm going to try option B, reflect over the x-axis and then translate 1 to the left. When you reflect over the x-axis, you change the sign of y, and then if I move 1 unit to the left, I would get not this number. So I'm going to cross off option B as well. All right, a reflection over the y-axis would give me -2, 1, and then translate 1 unit down would give me -2, 0. So C is the right answer. Number 5. If this triangle QPR is reflected over the y-axis and becomes a new triangle Q prime, P prime, R prime, what are the coordinates of P prime? Well, let's take a look at the original P point. P was originally 2, 1. And when you reflect over the y-axis, you change the sign of y. So P prime would be -2, 1. Question number 7. Describe a sequence of transformations that will take figure P on to its congruent figure Q. So I'm going to find a point here that I can easily match to its corresponding point there. My original point, I'll call it P, is 3, 2, and I want to get to my final point, which I'll call Q, which is -3, -5. And I need to figure out 2 moves that will get me there. So I'm going to change this point somehow to get a new point, and then I'm going to change that point somehow to get this red point. Well, I definitely know that I need to either rotate or reflect to get over to this other quadrant here. So maybe I'll consider a reflection over the y-axis. Let's try. Reflect over y. If I do that, I'm going to change the sign of my x value. Ooh, that's a match. That's pretty good. Now, how is this 2 going to become a -5? That's interesting. I definitely need to subtract, and I need to subtract 7. So I could translate 7 down. Let's give it a try. Reflect over the y-axis, so instead of 3 units to the right, I'm going to be 3 units to the left, and then 1, 2, 3, 4, 5, 6, 7 units down. That would work. Let's try another point just to be sure. How about this one here? Reflect it over the y-axis, and then 1, 2, 3, 4, 5, 6, 7 units down. It's a match. So we would write reflect over y-axis, then translate 7 down. Number 8 asks us, if we have a quadrilateral that has this point and we reflect it over the y-axis, what will happen? Well, anytime you reflect over y, you change the sign of x. So if I started with -7, 5, I will end with +7, +5. Number 9 is asking us about corresponding parts that are congruent, that are equal in length, right? So you are congruent, the same size. So you might remember us talking about the name of a quadrilateral and the name of its new image with the prime signs. And so we know that FG is going to be congruent or equal in length to F prime G prime. And we know that GH is going to be congruent to G prime H prime. So let's see what our options are here. FG and FJ, JF and HJ, GH, HG, HG, and HJ. Do you notice that this is the only option that has the same letters in it? FG, HJ, F prime, G prime, H prime, J prime. This is a pair, this is a pair. They're a matching pair. But we could also see it visually if I am looking at this side, this long side, G to H, and I look at this side, G prime, H prime, I notice that that is just a 90-degree turn. Number 10. If you take a shape and rotate it 180 degrees clockwise, and then dilate by a factor of 4, what's going to happen? Well, it's going to turn, and it's going to get bigger. So is the area 4 times bigger? I'm not sure. Is the perimeter 4 times bigger? Again, I'm not sure. Are the corresponding sides congruent? Definitely not, because I used a dilation. Are the corresponding angles congruent? That one is actually true. No matter what transformation you use, the angle measures are always congruent. And that concludes the practice for Unit 4 test.